So, some basic rules again that you probably already know is, of course, probability has to be a value between 0 and 1. So it'll always be decimals, can't be a negative. Probability of my sample space has to total 1, so all the outcomes, that's all the outcomes. The probability of those totals 1. That's why when we were doing simulation, we needed to make sure that all of our probabilities totaled up to 1 so that that made sense. And then probability of a complement, and I'm going to note that down here, means probability, that's how we read it, of a complement. And really what that means is not A. So it's going to be 1 minus the probability of A. So 20% chance of rain, which means there's an 80% chance of not rain, or rain complement. And then for the rest of these notations, I don't know how familiar you are with these from your previous math classes, but this is the probability of A given, that's how I read that vertical bar, B. We're going to talk more about conditional probability. You've actually already been doing some of it with your two-way tables, even though you didn't know that's what you were doing. And this next one is the AND symbol. So this is probability of A and B. And then the bottom one is your OR statement. So probability of A or B. Here's how I like to try and have students keep them straight, is this. Looks kind of like the N and. That's usually quite helpful for keeping them straight until you have that down. Some more vocab. Disjoint events means they're not joined. Another way to talk about that is mutually exclusive. In other words, they exclude each other. So they have no outcomes in common. In other words, there's no overlap. And so I can draw a picture of that. So this could be a card from a deck of cards and a roll on a die. In other words, I don't have any overlap between cards and die. Their outcomes don't overlap. So now, you have some formulas on your formula sheet for probability. And so you don't really have to memorize them, but you do have to know that they're there and what they mean. And so we're going to start with if events are disjoint, then the probability of A or B, so let's call those A and B, would be the probability of A plus the probability of B. And then the probability of A and B, well, I can't be in circle A and circle B at the same time, so that would just be 0 for disjoint events. Now let's look at not disjoint. In other words, they're joined or joint. And these ones are mutually inclusive. So they have overlap. So on the mutually inclusive, now my probability of A or B. So if you remember back to Algebra 2, where you probably learned that OR meant to add and meant to multiply, pretty similar here. So on the OR I'm adding, but here's the catch. If I take the probability of A, that's everything in circle A. And then if I take the probability of B, that's everything in circle B. And so now when I add those together, what's happened is I've added this extra overlap in twice. I've added it once as part of the green section and once again as part of the orange section, and I don't want to count it twice, so I must subtract the overlap. And if you look at your formula sheet, you'll see that this is actually the formula for OR. And so just to make sure that you realize that it is consistent for the mutually exclusive, I am in fact subtracting the overlap up here, but when I look at the picture, because they're disjoint, there is no overlap. As a matter of fact, that overlap